Move into our final topic today, which is concrete overlays for urban areas. Many of you are familiar with overlays. We started to see them become more and more popular throughout the state in rural areas. A photo taken here shows an 8-inch concrete overlay on US Highway 2 that was constructed just west of Grand Forks last August. Perhaps some of you on the call were part of our on-site tour of that project. But again, as Brian mentioned, these are great ways to add additional service life to existing roadways by coming through and putting a concrete overlay into service. One of the things that we have not been so good at here in North Dakota, and the reason why I've asked our next presenter to be here, is taking this overlay technology and bringing it into our cities and using it for urban street repair. It's been done in other parts of the country with much success. And so that will be our final presentation this afternoon when we have Todd LaTorella. Todd is my counterpart. He is the executive director in the Missouri-Kansas chapter of the American Concrete Pavement Association. Since I've taken over in this position, Todd has been a great friend and full of resources and helped me out a bunch, and I really appreciate him being here today. You know, in addition to the credentials listed on his screen, he's helped move overlays from a viable option from rural to urban areas, which is what we think we could have some benefit from here in North Dakota. We've asked him today to join us to share some of the challenges so that we don't have to maybe go through some of the hardships that they've done and that they've learned the hard way. So with that, let's welcome Todd LaTorella to talk about concrete overlays in urban areas. Todd, thank you for joining us today. We look forward to your presentation.
Where to go? Thank you, Art. Can everybody hear me okay?
Yeah, we got you coming through loud and clear. Thanks, Todd.
All righty. I trying to turn my camera on here. I don't know where everything disappeared to, but it's not important. You really don't need to see me anyway. So, but thank you very much, Art. Appreciate the opportunity to talk to everyone today. Great presentation so far. As Art mentioned, I'm here to talk to you about concrete overlays for urban areas. We've had a lot of experience both on the highway network, which is certainly the challenges. While there are some, are certainly easier to deal with than in the urban areas that we'll talk about. So I'm going to jump in. I know I'm the last speaker of the day, so we'll try to keep ourselves on time here. So just a little presentation outline. First, just want to define urban concrete overlays. Briefly review the family of concrete overlays and design theory, just so everybody's on the same page and up to speed. Talk to you about some concrete overlay design basics. And really the crux of the presentation, or the bulk, will be showing you some actual applications. I think that's a better way to kind of show you what we've done, and when we talk about the challenges, you'll get a better picture of that through different types of applications that we've done in Kansas and Missouri. Quickly show you some available design resources, and hopefully we'll have some time for some questions at the end. So, all right. So my loose definition of urban concrete overlays, basically any application on a non-highway facility in an urban environment, and this can include arterial collector streets, residential streets, as well as parking lots, and I'll show you examples of both there. And here's where we kind of jump into probably the biggest challenge and the biggest hurdle that we have when trying to come up with a concrete overlay option in an urban environment, because typically these overlays and applications will involve profile grade elevation constraints related to existing curb and gutter, drainage structures, driveways, entrances, side roads, you name it, that will influence the design. It's easy out on the highway network when we have open ditches and we can raise that profile grade and we're not tying into too many structures other than occasional entrance and bridges. That's a lot easier than when we have existing infrastructure in an urban area, in an urban application, and we have to hit all these hard points. So, and this really differentiates urban from more highway and typical roadway overlay applications. Now, real quick, just so we're all up to speed and on the same page with our family of concrete overlays when we start talking about them. I know the other speakers kind of got into this a little bit, but here you see the 4 traditional concrete overlays and the overlay products that we've had as an industry, as a concrete paving industry. And basically over recent years, we've kind of just narrowed that down to 2 basic families of overlays. We have our bonded overlays and our unbonded, and we really don't care anymore what the substrate is or the existing pavement is underneath. We just want to know, are we looking at a bonded overlay design and application or an unbonded overlay? And so here we have our family overlays, and see on the left side here, we have our bonded overlay systems. When we design those, the bond is integral to the design, meaning the design works because it's bonded to the existing pavement in some fashion, and that bond remains over time, over the performance period of the overlay. Because we're building a composite section there and we have that bond, these overlays are typically thinner, of course. On the unbonded side, we're basically just using that existing pavement or substrate as a base. So we don't worry about bond. If we get some bond, that's fine. But the design itself it's not imperative to have that bond for the design to perform as or to meet our expectation. And so those overlays tend to be thicker. The best resource out there, and probably the only one you really need, is the Guide to Concrete Overlays out of the CP Tech Center. This is the 3rd edition. Great resource. Everything you ever wanted to know about overlays, from scoping, design, construction, traffic control, repair, you name it, it's in that guide. I think there's actually a new version of the guide getting ready to come out again. But this is really a great resource, free download, cptechcenter.org. So I encourage you to check it out. There's that 3rd edition. And so let's jump into the applications here so we can really look at what we're talking about. We're talking about these urban overlay applications. I'll start off with a real simple one just to get everybody's feet wet. We're going to look at a bonded concrete overlay over asphalt. That's our BCOA. Is our acronym there. And this is probably the most common concrete overlay type for urban environments, or probably any environment, for a couple reasons. Of course, there's a lot of existing asphalt roadways out there, much to our chagrin sometimes, but that's what the existing system is made of. 90% of the roads are asphalt, so we have lots of overlay opportunities over in that market for BCOAs. And profile grade elevation constraints are a little easier to deal with when we're dealing with full depth asphalt pavements. Asphalt pavements are a little thicker to start with than concrete pavements. It's easier for us to mill asphalt pavements to address that profile or that elevation increase. And we don't have to worry about any embedded steel, dowel bars, mesh in old pavements, tie bars, that if we get into milling concrete, we got to make sure we're aware of that. And sometimes that can slow us down or be a little more costly when we're trying to mill concrete pavements with embedded steel and reinforcement in them. Here's a little schematic out of the CP Tech Center overlay guide. Basically, it just shows you from existing pavement to finished product. You'll see there in the middle, that's the area where we're basically addressing the bond. So typically in these bonded concrete overlay over asphalt applications, we are going to mill the surface. So we're going to prep that asphalt surface. We're going to cold mill it. We're going to get it nice and clean. Of course, when we bond anything to something else, no matter what it is, we always need 2 things. We need a roughed up surface, an increased surface area, and it's got to be nice and clean so we can get that bond between the 2 materials. So you're always going to have that when you have your bonded overlay application or design. Then, of course, as Brian mentioned, as far as the placement, not a lot different than conventional concrete. Just a little bit about joint design. This is probably the one thing in the construction that deviates the most from conventional concrete paving. Essentially, all the geometrical or the layout rules apply that apply to conventional concrete, but really the joint spacing for these overlays, especially the thinner ones, probably more of the overlays you're going to see in an urban area are going to be in this thickness, although we'll talk about a thicker one in a few minutes. But for these, 3, 4, 5-inch overlays up to 6, we really want to keep that joint spacing between about 3 feet to 8 feet. Really no bigger than 1.5 the thickness of the overlay. So instead of the 2 times rule we typically use for conventional concrete, we're going to be looking more at 1 to 1.5 times. Typically no dowels and tie bars in these designs or these overlays. Fiber's optional. There's a lot of advancement in fiber reinforcement technology. A lot of great fiber products out there that provide more of a structural enhancement to the concrete that make a lot of sense. They do add a cost, so we just want to make sure if we're going to use those, it's needed, and we're going to take advantage of that in a longer performance or possibly thinning up the overlay if we're going with a macro fiber type addition to the concrete. Saw on the joints, typically we're going to go less than 1/4 inch wide, kind of a single cut operation, 1/3 the depth of the overlay or slab, and for the most part we're leaving those unsealed. Now when we get into overlays 6 inches or greater, 6 inches always that right on the edge sometimes, but typically overlays 6 inches is greater, we're going to jump back to that 2 times rule where we can. I would probably still recommend, sticking to that 1.5. When I work with my consultants on urban paving projects, even full depth concrete, we're definitely reducing the slab sizes, the joint spacing. If it's 8, 9, 10-inch concrete, we're going with 12 by 12 foot panels, and kind of that configuration, and we're really getting great performance. You see, if you shrink that joint spacing down a little bit, you'll see very little chance, a little risk of getting some uncontrolled cracking outside the joints. And then you also want to be aware, as part of the joining rules, the thicker the sub base or the base we're putting that pavement on, so the stiffer that is, the shorter you want to make that joint spacing. So we want to alleviate some of those bending stresses in the slab. So if we shorten the slab and we're on a stiff sub base or base material, we always want to be wary of that and shorten up the joint spacing and design some smaller panels. Again, joints may be sealed or not, depending on the application. The industry still goes back and forth on that. I think a lot of us have some ideas about when we might want to seal joints and not. But for these thicker overlays, we can go with a conventional double cut joint construction and seal them, or we can stick with the single cut less than 1/4 inch and leave them unsealed. All right, so here we go. We got Project First Street in Abilene, Kansas. Basically, this was existing 9 to 12 inch existing asphalt pavement. It wasn't really that old. It was only about less than 20 years old when we built constructed the overlay. And essentially, design was pretty simple: 5-inch cold mill, 5-inch concrete overlay or inlay. So just kind of a mill and fill, but if you want to think about it that way, but with concrete. PCC mix, the concrete mix, nothing fancy. We did throw some microfibers in there at 3 pounds per yard, which that was fairly typical, probably in the early to mid 2000s. That was kind of a thought that, hey, on these thinner overlays, we're going to throw in a fiber mesh, was the hot fiber or the microfibers at the time, 3 pounds per yard. Help us a little bit with maybe some crack control protection, more with plastic shrinkage control. So we had those fibers in there. Just be aware that there is a difference between microfibers and macrofibers. So certainly if you're really looking for some structural type enhancement, crack control protection, maybe the opportunity to thin up your overlays, you're looking at the macrofibers. Joint spacing, nothing fancy here, 4.5 to 5.5 foot, and really that was a function of the street width more than anything. So based on the street width we had and laying out those joints, we ended up with 4.5 to 5.5 foot joint spacing. Again, we did single cut, less than 1/4 inch wide with no seal, no tie bars, no dowels. It was built in 2006 by one of our local contractors, Smoky Hill. And really, if you want to think about this, it's kind of a mix of the old ultra thin white topping technology we had and a white topping technology. And we've characterized this now as that BCOA, bonded concrete over asphalt. Just some shots of the project. You can see there's a grain elevator. Abilene's a pretty small town. Basically the home of Dwight D. Eisenhower and his presidential libraries in this town, but it's a pretty small town, but does have a grain elevator, and this road serviced the grain elevator, so we had lots of heavy trucks that were rutting the pavement pretty significantly. So the city and the engineer came to us looking for a product to address that, so we ended up coming up with the 5-inch mill and fill with concrete. You can see there's the milled surface. We basically did half the street at a time. You see on that upper right picture, we got that surface nice and clean, exposing the existing aggregate in the asphalt, and that's really what you're bonding to here. Is you're bonding to that existing exposed aggregate in the asphalt mixture. You can see there we put up a little form, and they made a little keyway with a split piece of PVC pipe. Probably not necessary. I'm not sure if that was on there for another reason, another project, and they just use those, but we don't need that keyway there. You can see we brought out the paver. Basically just went from one end of the job to the other. Bottom right, you see the curing compound. We always want to do a good job of curing with concrete, especially on these thinner overlays where we're dealing with a much thinner section. We're often putting it on a fairly warm material. That existing asphalt can get pretty hot sometimes. So we want to keep as much of that moisture in the concrete, get that hydration process to do its work to its maximum, so we get the most durable and high performing concrete we can. So always, we don't like to see a lot of gray. We want to put that curing compound on 150 square foot per gallon. I like to see, make that surface nice and white. Just another shot. Once we got the one side done, strip that form off, just use the existing, the first phase as our form at the center line there. Actually brought a bunch of folks out from KDOT for a little showcase there. We went out to look at the project while it was under construction. That's why you see all those inspectors out there looking at the concrete going down. And there's a shot of the finished product and the finished project taken in 2013. Still performing really well after now 14 years. Again, 5 inches thick, nothing fancy, a little microfiber in there. Really quick to construct, great project, turned out really well. We've actually done a couple others in the city of Abilene for the owner. Another application here real quick, very similar type project, maybe a little higher traffic on the volume side. This is South 9th Street in Salina, Kansas, just about 20 miles west of Abilene off I-70. Again, we had 11 inches of existing asphalt pavement. We did basically the same thing, 5-inch cold mill, 5-inch concrete overlay. So just again, a mill and fill with 5 inches of concrete. Nothing fancy about the mix. Again, 3 pounds of microfiber per cubic yard, kind of the standard that we were working with at the time. We had 12-foot lanes, so we went with 6 by 6 foot joint spacing. Again, just a function of the street width. Single cut, less than 1/4 inch wide with no seal, no tie bars, no dowels. Opening strength, always something to really to look at and really try to identify what type of opening strength you really need, because these overlay projects, especially in an urban area, we're dealing with traffic, we're dealing with the public, we're dealing with businesses. One of the benefits of these concrete overlays, we can build them really fast, little inconvenience to the public. That opening strength can have a big bearing sometimes on how quick we can turn the project around, how much the mix is going to cost. So there's no reason to what we're finding out is there's really no reason to have 3,000 and 4,000 PSI opening strengths. 2,500 is plenty. I think as an industry, we're probably even going less than that for these types of projects and not having any issues. This project was constructed fall in 2008 by one of our local contractors in Salina, Pavers Inc. Again, kind of a mix of the old UTW technology and white topping, characterized as a BCOA. Existing pavement was kind of just stretch of an arterial street between two intersections that were already concrete. So the city had already reconstructed two intersections on either side of this section of pavement in concrete. And now we had this existing asphalt street in between that they wanted to address. Basically very similar to the previous project. We just went out there with the milling machine, milled that 5 inches off. It's kind of nice because you can mill one day, put traffic, or days before, put traffic on that milled surface, go out, get it cleaned when you're ready to pave and place the concrete pavement. You can see there they're basically blasting, sand blasting, air blasting the existing asphalt, high pressure air blast to get that surface nice and clean, as you see on the bottom right. Exposing that existing aggregate in the asphalt, which you can see there.
Hey, Todd, this is Art. Before you move on, I hate to interrupt, but we do have a couple of questions that came in that deal with, this preparation slide. So I think it's timely to take a look at it. The first question is, do you need to mist the milled surface with water before paving the concrete? So once you have it clean, as you're showing, would you recommend misting it with water?
Yes, that's a very good point. We would definitely recommend misting the pavement. What you don't want to do is you don't want to pond water on the pavement, but you do want to cool that surface down. So I'm trying to get back to my presentation. But that's a very good point. We don't usually in the spec for these types of projects, we do have a temperature requirement in there for the asphalt. So we never want to place concrete on something really hot and basically cook the concrete. So we want to get that temperature down. I'm trying to remember what that temp is. I want to say somewhere less than 120 degrees, but usually we want to mist that pavement. Or if you do put water on the pavement, you can go back with an air blast if you do get some puddles and just blow those puddles off. And usually for our environment down here in Kansas, it's pretty hot during construction season. So you want to do that misting fairly, pretty much right before you're going to do the concrete paving. If we do it an hour or two before, it's not going to do you much good because it's going to dry. That pavement's going to dry. It can be basically surface saturated dry is what you want. Okay. Was there another question there, Art?
Yeah, and there's one more, and then I'll let you get back to it. So I do apologize.
No problem.
The other question is diamond grinding for ride incentive specs required for all rural concrete road projects? And how soon can grinding be done after you pour an overlay?
Diamond grinding is really a function of the concrete strength. So I think if you talk to our sister association at the International Grinding and Grooving folks, you basically want the full strength of the 28-day full strength of the concrete developed before you do the diamond grinding, which again usually you're hitting that design strength well before 28 days, but a lot of times in the spec it'll say 28 days or the full strength development of the concrete, which for us would be 3,800, 4,000 PSI. I will tell you, we constructed some of the longest stretches of 6-inch concrete overlay in the country on I-70 in western Kansas, 6 inches thick, and we got super ride quality on that project without diamond grinding. Mainly, one of the reasons is when you only have a 6-inch head of concrete and you're placing it with a slip form paving spread, you don't end up with that as you're extruding that concrete through the paver. You don't have near that head of concrete basically that's making it kind of hump up behind the screed. So we really got super ride results, paving a mile and a half a day with that paving spread and getting super ride numbers without grinding.
Okay.
If you're in an urban area, I'm going to tell you, and you have a bunch of blockouts, you're doing 1,000 feet here, 1,000 feet there, blocking out for a business. You have other existing pavements and structures you're trying to hit. You might want to put a grind in the contract. So if you're going to build in roughness to the pavement during the process, instead of going back and doing bump grinds and which is great, it gets it back to 100% pay in those areas, but it doesn't look good aesthetically, which is always nice for the pavement to look nice. And you'll notice that when you hit the grind sections, you get a really super smooth ride, and then you get back to 100% pay sections, and it doesn't feel as smooth. So I would always, if you think you're going to have an issue with smoothness or have to do quite a bit of bump grinding, I would just put a grind in the contract. You're going to get a much better price. You're going to get nice, uniform, quiet texture with that diamond grind. I would do it that way.
Okay, sounds good.
You could see on this project, it was just a stretch of pavement between two intersections. So there was really no reason why we shouldn't get a nice smooth pavement here on this project in Salina. It was just a straight shot without much of a problem there. So I know there's no grinds on that project. Good questions. Anything else, or does that cover it for now?
That's it for now, but I will keep you posted as questions come in. So thank you for answering those.
All right, great. And the other thing with diamond grinding, a lot of the expense of diamond grinding is the mob of the equipment. So to get that equipment out on the job site is a large portion of the expense. So while it's out there, if it's, if they're going to be doing some work and touching up the surface, and a lot of times it's almost better just to say, hey, let's just put it in the contract. Grind the pavement when it's done. 100%. Again, nice uniform texture. It's quiet, super smooth. Really makes the project turned out even better when you do it that way. Here you go. In this case, they just use a vibratory screed. Working off the existing curb and gutter and the existing pavement, or the first phase of the pavement there. You see the 6 by 6 foot joint spacing there. You just got the longitudinal joint down the middle of the lane at 6 feet. Again, nothing special. Did some night sawing there, and then you see the finished product. I will tell you on the sawing in the urban areas, I don't know about North Dakota, but I know down here in our area, the noise is a big issue. A lot of cities have noise ordinances that we have to work around now, which basically requires us, does not allow us to saw at night anymore in a residential area. So that can create some issues. So we really have to, when we schedule our paving, we have to be aware of, hey, we can't pave after 3, 4, 5 o'clock in the afternoon because we know we're going to be sawing at 10 o'clock or midnight. So be aware of that, or sometimes the cops might show up and shut the sawing contractor or subcontractor down. So, all right, another project application. Here's a parking lot application. This is Twin Chimneys Elementary in Fort Zumwalt School District. It's in St. Louis, Missouri. This is one of our early projects where we did a concrete overlay on the existing school parking lot. We've now done about 30 or 40 of these over in the St. Louis area, and they've really turned out great. And got 3 or 4 school districts that really love these. So if you want more info, we have tons of info on these projects over in the St. Louis area. This project has about 120 spaces. It's got an entrance and a drop-off lane and a bus loop built into the parking lot that I'll show you in a minute. Here, the design we did 4 inches basically in the parking stall areas, 6 inch in the bus drive areas. So anywhere where the buses were consistently driving, we beefed that up to 6 inches thick to address the bus traffic. Again, we use that 3 pounds of microfiber, no steel, 4 to 6 foot joint spacing based on the 2 different thicknesses. Single cut, less than a quarter, no sealant, no joint sealant. Very similar mix of UTW and white topping technology. And basically we characterize this as a BCOA in some areas and an unbonded overlay in others over asphalt, which I'll show you in a minute. So here's a schematic in the concrete overlay guide for unbonded concrete overlays over asphalt. Very similar to the previous one. The only thing you'll notice is it does not require milling. So we're not trying to establish a bond. We don't necessarily need to mill the pavement off unless we're addressing profile grade increase, or there's so much surface distortion in the pavement that if we milled the surface first, we'd end up saving or limiting the volume of concrete we're going to need to fill that area. So sometimes it's less expensive to go out, profile mill the existing pavement so we're not overrunning. I don't like to say overrun because I don't believe it's a overrun really, but we're decreasing the volume of concrete we're going to use out there, which there can be a cost savings in that. So you kind of have to take that into consideration. And then you're placing your overlay just like we talked about before. Here's a bird's eye view of our plan shot of the school and the parking lot area. You can see the red there's where the bus lane or the 6 inch section is going to be. Don't look at those thicknesses on the plan sheet because we actually used 4 and 6 inches. And you see the yellow, the parking stalls, we basically went with 4 inch, a 4 inch thickness. This is a good shot because it really shows you sometimes owners and engineers ask, well, how bad a shape can the asphalt be in? It probably needs to be in good shape, right? Well, in order to do a concrete overlay. And that's not the case in a lot of applications. So you can see here, this existing school district parking lot and entrance roadways, it was pretty badly oxidized. We had some rutting and some minor structural issues out by the dumpster. We got potholes and some moisture issues, some block cracking. So it's in pretty rough shape. And really this pavement wasn't that thick that we were working off. But the one beauty here is we were able to raise the profile grade when we got away from the school building because we were in a, we didn't have to meet a lot of existing structures or other objects once we got on into the larger parking lot expanse, the parking area. So that helped us with not having to mill down where we didn't have a lot of asphalt to deal with in the first place. So here, this was all hand placed. So the contractor just went out, formed it up, basically all hand placement. You see a few shots there. The upper shots, they're out in the parking lot area. Bottom right, they're actually working on the entrance road. Here's another shot. You can see in this, it's fairly obvious that we didn't mill the existing asphalt out in the parking lot. You see the yellow stripe still for the parking stalls. You'll also notice what I was talking about before with the variable thickness. So you'll see there we had a minimum thickness of 4, but we had, variability in the existing or the existing profile. there was some variability in that. It was not a uniform cross section or profile we were working off. So we ended up with some areas of where the overlay was thicker. So of course, in those areas, doesn't matter what we fill them with, we're going to need more material. So sometimes it's kind of a guessing game about how much material are we really going to use out there, because if we base our quantity off our 4.5 inches, and we have some areas out there that are 5 and 6 inches thick, your concrete quantity is going to be a lot higher than everybody originally thought. And that's okay, except usually there's a debate about, well, who's going to pay for that? The contractor wants to get paid for the concrete they used, and the owner says, well, hold on here. We didn't have that built into the contract to pay you for all this additional concrete. So we kind of want to address that up front, either by, most of the time the way we do it now is you really go out and do a pretty detailed survey of the existing pavement, get that all set up, and then calculate, if we set the minimum thickness of the overlay at 4 inches, how much volume of concrete are we going to need to meet our profile, to meet our smoothness, to meet our minimum thickness? And then we go from there. And then sometimes we might say, hey, it'd be better to go out with a milling machine if we have enough asphalt, do a profile mill, and get that surface, that existing profile, a lot closer to the final profile so we can cut down that volume of concrete. So you see there, finished product looked really good. Again, this was June 2008, if I'm reading that correctly. And so this is really a good time to talk about the other item that comes up a lot as it relates to quantity and volume of concrete. So here we have an existing pavement, and the existing pavement has a pretty good uniform profile and smoothness, both cross slope profile and profile down the road. We design our overlay. If they match up perfect, then really if we spec a 4-inch or a 6-inch concrete overlay, we're going to have concrete overruns typical to what we would for new construction. That's great, but that situation doesn't exist very often when we have existing asphalt pavements. So in this situation, everything works out perfect, and you could, and it'd probably work out if you bid this project as concrete by the square yard. So you just said, yeah, the project requires 20,000 yards of concrete. We're just going to bid it 4.5 inches for our volume, and we're just going to put in a bid item for square yards of concrete placed and provided. Just one bid item. That situation doesn't exist very often. So the reality is we have a surface that has a lot of undulations in it. It's not uniform either from cross slope or profile, as asphalt tends to move around during the course of time. So we're not dealing with a profile that's close to our final profile. So when we drop that concrete overlay on there, you can see there's going to be some areas that we're going to have to fill in with concrete to address the profile to meet our minimum thickness, our smoothness, our cross slope, and our final elevations. So that volume is the volume no matter what you fill it with, which is the reason I don't like to call it overrun. It's just the amount of material it takes to get you your final product and those minimums that you want in terms of thickness, cross slope, and smoothness. So in this situation, what we'd really like to see owners do, and it really takes a lot of the risk out of the jobs for both parties, the owner and the contractors, is bid the overlay with 2 bid items, one for placement of the concrete, so the actual physical placement or the construction of the overlay, square yards, and then pay for the volume of concrete on a cubic yard basis. And this really is the safest and least risk for both parties. So you're building the placement by the square yard and the material by the cubic yard. And that works really well for these situations. And then you don't get into those arguments at the end about, hey, we used 25% more concrete, which can happen. That's a realistic number than we thought. Just basically addressing the challenges and the issues with the existing profile. So here, profile grade increase, how did we handle that up against the school? You can see there in the upper, the right side of the screen, what we did is we basically, because this pavement was in pretty tough shape and it wasn't that thick to start with, we really didn't want to start milling in there 2, 3, 4 inches and have the milling machine start to break through the existing asphalt, because then we have to address those areas in some fashion. It slows us down, it's more costly. So in this case, we basically just raised the profile, as you can see there, and we raised it up so it was flush with the sidewalk and the walkways there, and that worked out really well when we got up against the school. And there's the completed paving. Again, turned out really nice. This project's 12 years old now, performing fantastic. You got the nice light bright surface, for the lighting and the safety out there for the students and the staff. It's nice and cool surface as well. We've actually recently done some playgrounds, and that was a big benefit, with the children playing out on the concrete overlay surface. It was a lot cooler during the summer months. So that was great. So these were applications where there was no traffic on them at all other than foot traffic. And then here, if there's no questions, Art, the last project, and this one is kind of something a little different, but it kind of shows you what you can do if you think a little bit outside the box, and basically say, hey, we're going to go into this project with the mindset of coming up or constructing a concrete overlay for this application. And this is an intersection project in Salina, Kansas again. The existing pavement was kind of a hodgepodge of full depth asphalt and composite pavement. And this is probably what you'll find in a lot of cities, is older cities, is the existing pavement is all sorts of things. It's got utility patches in it with concrete. It might have some old brick in there if they're really old streets. So you never know what you're going to find out there. And we'll talk about it in a minute, which is why you always want to go out there and do a fair amount of coring to make sure you understand when you go into the design and the construction that you know what you're going to run into once you get into the job. So for this project, it's really high traffic. I'll show you in a minute. The city really wanted a long-term product out here. They knew this was going to be a little bit of an inconvenience. So they wanted this concrete overlay to, give them 30, 40 years of performance. So we decided on an 8-inch concrete overlay, dowel reinforced. The non-reinforced dowel jointed, 12 by 12 foot joint spacing or panels, 11 foot in some areas because of the roadway width. In this application, we did a double cut on the joints, 3/8 inch wide, and sealed the joints. It was constructed in 2012 by Pavers Inc. again, our contractor out of Salina. And this is a mix of white topping and unbonded overlay technology over concrete. And we also incorporated the geotextile inner layer for the unbonded portion. So this was a cool project. The other thing you want to notice about this project is we mixed and matched overlay technology. So it's not a problem. Again, if we know what's out there and we know what we're going to run into once we start milling or getting into the existing pavement, we can come up with all innovative overlay designs for the different situations. So that's not a problem. Again, really cool, interesting project. So here's the schematic for the unbonded concrete overlay over concrete. You see there we got the asphalt separation layer that historically or typically we'd use between the existing concrete and the new concrete overlay. In this application, instead of bringing in an asphalt operation to place that 1 inch of asphalt to separate the existing pavement from the new pavement, we use the geotextile paving interlayer fabric that I'll show you in a minute. Purpose and need, I'll give the HWS or my friends at Benish Engineering credit for this. This was out of their presentation that they gave at one of my events down here about how they came up with this design. So the purpose and need, the pavement was in really rough shape from a condition standpoint. It needed some type of rehabilitation. Very high volume intersection, probably the highest in Salina at 35,000 vehicles a day. They were having a lot of recurring maintenance, which is why they wanted to, which was the purpose of the project. One of the goals was to eliminate that and reduce that maintenance. And they needed it for a detour for another project in 2012. So they wanted to get this job done because they wanted to use the part of the detour for another project would be using this intersection. So we had two major arterial streets. We had Ohio Street, one of the big arterial streets in Salina. You can see it ranged from 11 to 15 inches of asphalt, full depth. And then we had Crawford Street, which is another arterial that comes off of I-135, which is one of the other projects that we were detouring, that we were doing work on, so that the detour traffic from the I-135 project was going to be using this interchange. And that ranged from 1 3/4 inches of asphalt over 7.5 inches of concrete to basically the 7 1/4 inches of concrete with thicker asphalt sections on it. So it was, again, it was really a hodgepodge of existing pavement out there. They kind of came up with a pros and cons just list here for looking at a hot mix asphalt overlay versus a concrete overlay. So you see the pros for asphalt. These are nothing that you probably wouldn't normally think of, right? Asphalt overlay, right? We're in and out of there quick. Doesn't take a lot of design effort. Maybe a less of initial cost. That's not always the case. Construction schedule might be quicker, and construction sequencing might be easier for us. The cons with the asphalt, of course, higher long-term costs. So they expected to do more frequent maintenance if they went back with asphalt. They thought they'd be back within 4 to 7 years. So that was a con, after inconveniencing the public. They didn't, and the businesses, they didn't really want to show back up there in as short as 4 years doing maintenance work again. And so it really didn't meet the project goals, which then kicked us over to the concrete overlay side. So the pros, a little longer, but basically it's the get in, get out, stay out motto was the pro for the concrete overlay. Lower long-term costs. So we had the expectations of once we got this built with concrete, we were going to have much lower maintenance and less frequent maintenance out there. It allowed for future widening of the project. Construction schedule, as we'll show you the phasing in a minute. Construction sequencing. So even with concrete, we can do these projects really fast and on a short time schedule. Sequencing can be handled, as I'll show, and maintenance of traffic, as I'll show you in a minute. Again, we're going to stay out. We won't be back for a while. And so the concrete really met all the project goals that were set out by the owner to the engineer. The cons, a little more design effort, as I already showed you. We had some existing conditions that we needed to deal with in different ways, and the construction limits. Certainly, a 2 or 3 inch asphalt overlay is going to be a heck of a lot cheaper first cost than an 8-inch doweled concrete overlay. So essentially what they did is they shortened up the construction limits of the project and really did the 8-inch overlay where they knew they needed it and to hit the business entrances they wanted to hit, and then they just overlaid, put a thin overlay on the sections outside of that. Design concerns, we wanted a smooth ride, as somebody mentioned. We did not want to raise the grade, so we wanted to be able to keep that profile and hit all those existing structures and other pavements and entrances and existing pavement that we needed to hit. We wanted to maintain the drainage. We wanted to make sure we didn't punch through the existing pavement, meaning once we milled that pavement down, we didn't want the milling machine punching through. And that question always comes up. Well, how thick does the existing asphalt need to be or pavement need to be for us to use it to construct an overlay on? And how much can I mill down? Well, basically what you want to do is you don't want to mill a pavement to the point where the milling machine's falling through the existing pavement. Because what that's going to do, it's going to slow you down. It's going to require you to do a bunch of repairs out there and address those situations. And it really takes away the cost savings and the expedient nature of these projects. So that's really the standard we use. If you can keep the milling machine from falling through, then that's really why you want to limit that depth of milling for the concrete overlay. How to handle punch throughs? Hey, if milling machine does punch through the existing asphalt, we want the contractor to know at that time what they need to do. We don't want to have to stop the project, call somebody, get some folks to come out to the job, say, hey, this is what we have. What do you think we should do? We want to have all that lined up in the project plans and specs. So when we do hit that situation, everybody knows what they need to do and it's all laid out and we can just keep on going. Maintenance of traffic, that was a big one on this job with 35,000 vehicles a day. Balancing project limits with construction duration. There are businesses around this intersection, so we had to worry about business access. Contingency plan, we just talked about that. And you can never have enough cores, so you need to go out there. What you don't want to do on these overlay projects is just take the existing plans off the shelf and say, hey, the existing plans show this much asphalt, this much concrete. We kind of did these actions over time. That's what's out there. You will get burned if you do that. I guarantee it. So you always want to go out there and take as many cores, and really you can't take enough to make sure you identify what the existing pavement is out that you're dealing with and how thick those layers are. Because I think you'll be surprised, especially with asphalt pavements, the variability and thickness throughout the asphalt pavement sections, because they can vary by 2, 3, 4 inches sometimes over the same project. And as you can see here, the city was really freaked out about this project. People thought it couldn't be done, thought the city, the engineers, and our industry was crazy. The paper had Carmageddon in there. It was going to shut the whole city down, get prepared. Again, we're talking about Salina, Kansas, not LA or New York, but people still freak out even in small towns about inconvenience or doing road construction. So that was the headline we were dealing with. We kind of convinced the owner and the engineering firm, hey, we got it. Just tell us what you want. Tell us the schedule we need to meet, the times we need to meet, the traffic delays and road closures you can live with, and we'll take it from there. Here's the typical sections for the street. Here's Ohio Street. You'll notice there we got the 8-inch dowel jointed pavement after we profile milled. And then we have the geotextile fabric. So in this area in Ohio, once we milled down, we were into existing concrete. So now we're placing this concrete overlay on existing concrete surface. So we need that separation layer in there, that geotextile separator inner layer in there to separate the new pavement from the old pavement, so we don't get any reflective cracks coming up or joints coming up through the existing pavement into the new overlay. Crawford Street now, this was full depth asphalt, right? So here we got our 8-inch pavement. And here, what we thought, hey, there might be some areas here in this existing asphalt section where the milling machine's going to punch through. If that happens, what we're going to do is we're going to hog that existing asphalt out. We're going to regrade it. We're going to throw out 9 inches of aggregate base with geogrid to address these sections. And we're going to go down the road. We're going to quickly install that, and then we're going to place the 8 inches of concrete over that. So that was our contingency for that. There you see the geogrid. So it was kind of a mix and match of overlay technologies again. Here's the construction sequencing, pretty standard quadrant type construction sequencing. We're doing it in 4 phases, each quadrant at a time. Traffic was reduced to 1 lane. So we're talking maintenance of traffic. We reduced traffic to 1 lane in each directions. No left turns allowed at the signals or entrances in the work zone. 20-mile-an-hour speed limit. Actually had the police force out there monitoring the project. And you can take this one for a plus or a minus, depending who you are. But they wrote over 500 traffic tickets during the course of this project. So I'm sure that upset the folks that got the 500 tickets, but that probably brought in quite a bit of income to the city in violations and fines paid. So, so even with the 20-mile-an-hour work zone and the cops out there, they still wrote 500 tickets. So. Original contract was 426, roughly $427,000, about 3,200 square yards of concrete, 400 tons of asphalt, which was the asphalt overlays they did outside the overlay section, tying back into the existing streets. Replaced the curb and gutter sidewalk, sidewalk ramps, inlet tops on all four corners of the intersection. And then also that cost included the base repair that we talked about with the 9 inches of aggregate and geogrid that we had specified if we ran into those situations where it was needed. So basically for that, you can just put in a unit price for these things, since you really don't know how much they're going to be or when you're going to run into them. So you already have a agreed upon price. So we're not haggling over that, when the situation arises, but it's already in the contract. So if we run into that, we know, hey, if we're doing this many squares, or that we need this many tons of rock and this many square feet of geogrid, this is what the cost is going to be. And this is going to be the cost of placement. Here's the milling construction. Just real quick, you can see there's some base work. So we ran into a spot where we kind of had a soft spot out there. Here's the area where when we milled down, we exposed the existing concrete. So we placed that geotextile inner layer down. You just roll that stuff out, nail it down on about a 6-foot grid with concrete nails and washers there to keep that fabric down so it doesn't blow. Again, this fabric's black, so summertime placement, you want to cool that fabric down. So you always want to wet this black fabric down. There's also a white version where that's not needed, but the black version, certainly it absorbs heat. So we're going to want to wet that inner layer down beforehand, so we cool it down before we place the concrete. There's our dowels and tie bars being staked down. Concrete placement. Nothing special there. And then we double cut these joints and sealed them with a hot pour. Nothing fancy. Here's a situation where we ran into an issue where we had some concrete that was in bad shape that we needed to repair. Soft spot, either could have been a utility patch. You never know under there. That was done over the years. So we want to make sure we have contingencies in the plans and the specs to address these situations. Don't fear the unknown, right? Be prepared for it. So there's that soft area I showed you before. We just hogged that out with the milling machine a little deeper and threw in some compacted some millings in there to address that situation. Remembering once you get the 8 inches of concrete on that, there's no concern there. So the biggest thing with these soft spots and these distressed areas was, can they handle construction traffic? When we back that concrete truck down the grade, is it going to be punching through and distorting the base? We didn't want that to happen. So in a lot of cases, the existing pavement needs to be able to support the construction traffic. And it's the reason for the repairs is not necessarily for the concrete overlay performance itself. Here's that rock going down, that aggregate material with the geogrid for those situations where we needed it. There's kind of the finished sections. Again, we're staking down the baskets and the tie bars, forming the, putting the place, basically staking down the place in the concrete forms. Here's an area where they found basically a void under the pavement. So either we had an old a water leak or a water main break, or for some reason we ended up with a big void underneath the pavement where you could kind of crawl down in. Basically, the repair for this is we filled it with like a fly ash slurry grout is what we did there. Kind of a, what would you call it, flowable fill type application. Had that set up, and then we could go on with the 8-inch concrete overlay. Constructing the pavement, again, vibratory screed there on the forms. And basically we went from this, the existing pavement, existing project or roadway, to this. It turned out really nice. It was open to traffic in 45 days. So despite the prognostication of Carmageddon, which didn't happen, we got the project open in 45 days. Basically got a 30 or 40-year product out there that the city won't have to deal with. People won't have to be inconvenienced. You can see there we got a what's that, one of those fish places, an A&W there on the corner. So we have some businesses that are not going to be inconvenienced again for a long period of time. Hopefully people by then will forget we were ever out there, and I'll be looking forward to the next project 30, 40, 50 years down the road. So just to sum it up, things, urban overlay success, what are the keys? Know what you're working with. We talked about it. We really need to know the existing pavement type and thickness. We need that for the design, but really important once we get into the construction to make sure we have contingencies, a contingency plan for situations that may arise if we get into some different pavement thicknesses, some different pavement materials. Again, you can't take enough cores, get your geotech folks out there, take some cores, know what you're getting into, know what you're dealing with. From that, select the appropriate overlay type. Again, we talked about the thinner ones, 4 and 5 inch bonded. We also talked about on the last project an 8-inch unbonded. I don't think most people would think you could do an 8-inch unbonded in the middle of a city on some urban arterials, but if you have enough pavement there and you come up with a good design and plan, you can do it. What's the surface prep going to be for the bonded versus the unbonded? What's the thickness of those overlays? How much profile and elevation increase can we live with? How much existing pavement can we mill off? And we kind of work our thickness from there. How long do we want the overlay to last? Typically a 5 or 6 inch overlay will probably get you 20, 25 years pretty easy anymore. We got 6 inches out on the I-70. It's already 10 years old. It's a 20-year design. It looks like it's easily going to make it. So 6 inches of concrete over existing asphalt or existing concrete last a long time, carry a lot of traffic. Joint spacing, what's our overlay thickness? What's our overlay design? What are we putting on? Come up with our joint spacing. Again, establish a plan for base or subgrade issues that may arise. Be prepared. Have a bid item for those things so we're not arguing or haggling about them during the project or after the project. Develop a construction phasing plan to minimize disruption and maximize productivity, knowing that the contractor may come up with something more innovative, the low bid contractor that gets the award of the job. So have some ideas or have some stipulations that the contractor has to meet, give them to them, and if they can come up with a more quick and easy way to construct the pavement in a better fashion with less inconvenience to the public and the businesses, why not let them come up with some innovative solutions that meet your criteria? And always remember, sometimes it's better just to close the road. Maybe you get the job done in half the time or a third of the time. Yes, the road was closed, but you get it done a lot quicker, may save you quite a bit of money on the project. And you tend to maybe end up with sometimes a better product and a better project if you just close the road and knock it out without having to deal with construction and maintenance of traffic during the construction. Again, establish a reasonable pavement opening strength based on design and traffic. I think we're finding as an industry and a lot of our agencies are coming to the conclusion that we can open traffic or open pavements to traffic a lot quicker than we ever thought. I can tell you in Georgia, they open up their interstate pavements at 1,200 PSI to 200,000 vehicles a day on the interstates around Atlanta. So 1,800, 2,000, certainly 2,500, you can open these pavements up, especially to lighter car type traffic where you don't have a lot of trucks. And use maturity. These jobs are great for maturity. I think you're crazy if you're not using maturity on a project as a contractor where you're dealing with maintenance of traffic in an urban setting with businesses. It's a lot easier. You can turn construction around a lot quicker, open pavements a lot quicker. It's really a great way to go. Establish those appropriate bid items, right, for the repairs or the situations that may arise. And also make sure you're addressing the square yard, cubic yard placement. So if you know it's going to be difficult to ascertain what volume of concrete we're going to need based on the existing existing pavement condition and profile and cross slope, use the square yard, cubic yard method to bid the project. It's going to take the risk out of it. You're going to get lower bids. It's going to be a lot better than if you do happen to use 25% or over on the concrete 25%. You're going to have a debate about, hey, the contractor wants to get paid for that, and the owner's going to say, well, I wasn't prepared for 25% more concrete being used on the job. So go out, survey the project while you're coring it, know what you're dealing with in terms of existing elevations and profile. Develop and design the project from a plan and spec standpoint, not with the conventional reconstruction approach. View it and develop the project and a design and construction with a rapid or fast track mindset, right? The benefit of doing a concrete overlay is it's quicker, it's less expensive, it's less inconvenience, and go into it with that mindset that, hey, to satisfy this or get the most benefit out of doing the overlay, we really need to treat these projects in a different manner, in a more rapid, fast track manner, fast track, rapid set mindset. So go into that way, think outside the box, right? Don't be afraid to give your contractor, your industry leeway or the opportunity to innovate. A lot of times they can come up with better ways. I got some contractors, like I'm sure Art does up your way, that are pretty innovative thinkers that come up with some pretty neat, expedient, cost-efficient ways to manage and construct projects that, on the design side or as an industry person, we often we don't think of these things. But them being out in the field all the time, they can come up with some great innovations, time savings and money savings. And despite what our industry would like to do and say, hey, concrete overlays are no different than asphalt overlays, they are. It takes a little more thought to come up with a good concrete overlay design and spec. These things need to be engineered. As an engineer, I find it pretty refreshing to go out there and, hey, give me an existing situation, existing application. I guarantee you we can come up with a concrete overlay design or engineer a concrete overlay solution. May not be the cheapest. It may not even compete, but we can certainly throw out an alternate or solution that can be considered. A lot of situations that can compete, but I don't think there's a situation out there that we can't really come up with a concrete overlay design or solution to at least be considered. Software tools. I mean, Eric talked about pavement designers, but there's all sorts of different overlay tools available to you for designing concrete overlays, depending on what type of overlay it is. Again, everything from highway overlays with the AASHTO Pavement ME product down to the pavement designer, city streets, parking lots, you name it. BCOA, we have a mechanistic empirical design procedure for BCOAs. Colorado has an overlay design procedure for 6-inch overlays that they use, just a spreadsheet. All sorts of different tools out there for you. You can go to the ACPA website, of course, and get a lot of those out of their app library, acpa.org/applications library. Again, just remember family of concrete overlays. Really, we only have two types anymore: bonded overlay systems and unbonded. It doesn't really matter what's underneath. We can come up with a design or a engineered concrete solution. Available resources: acpa.org, cptechcenter.org. You can download that overlay guide and all their great resources. Portland Cement Association, cement.org. There's my email address, or Art can get a hold of me. And there's our website. And with that, I'll, with football season and with us trying to run it back this year, that's the slogan. Are there any other questions, Art?
Yeah, we just had one, Todd. What are you seeing in construction activity in terms of price between, concrete and asphalt in your market when you're allowed to do alternate bids? Are you winning concrete projects, on the first cost, or are you looking at life cycle, or, what is the fluctuation between concrete and asphalt pricing in your area?
Very good question, and thanks for asking. So it kind of varies. I mean, Kansas and Missouri, like North Dakota, are pretty big states, so it kind of depends where you are. I will tell you, in Missouri, Missouri DOT bids every project they put out of any substance as alternate bids. So we've had 200 or 300 alternate bid projects over the last 15, 18 years. So every job that goes out of any substantial thickness, it has an asphalt option and a concrete option. It does include a life cycle cost depending on the size of the job. And I will tell you, concrete wins about 75 to 80% of the time. And there's only been 5 jobs ever where the life cycle cost, so out of that 200 jobs, only 5 have been decided because of the life cycle cost adjustment. So most of the time when concrete wins, it wins on first cost, whether it's reconstruction or a concrete overlay. So that's in Missouri. So we compete really well. Kansas, probably not as much. I would say there are jobs where we do compete on first cost, and there's jobs where it does take the life cycle in some cases, and there are jobs we don't win. I mean, one of the things you got to remember is we're not asking anybody to, if we put out a concrete overlay, we're not assuming it's going to win every time. But we think in a lot of cases, in a lot of situations, our products will compete really well. If nothing else, it'll probably get you a lower overall project cost, even if it does go asphalt. But it really just depends. So if you go out into western Kansas where materials are scarce and everything's got to be hauled a long way, certainly the prices are a lot higher. Again, urban projects, it depends too. It really matters if it's a really chopped up job and you can only do short runs of concrete. Certainly the price goes up. If we can do more high production, concrete is much more competitive. If we can do monolithic curb and gutter on jobs, which we do on some projects, we're a lot more competitive. So it really depends. But I don't think you should just go into these projects thinking, well, concrete can't compete. If nothing else, I think it's worth it, and you're probably going to save money in the end if you throw out that concrete alternative or opportunity or solution and allow the contracting industry to bid it. If it goes concrete, great. Art and I are really happy. If it doesn't, hey, we appreciate you giving us a shot. Maybe there's things we can change on the job that would make us more competitive going forward. But I'll bet you get a lower asphalt price, because we see that all the time. MoDOT actually tracks that, Missouri DOT, and they say, they're getting 5% lower prices when on these alternate bid jobs versus straight one pavement projects, basically, where they're just specifying one pavement. So I hope that answers your question. We use life cycle a lot, especially on the DOT side. I know life cycle cost adjustments are hard sometimes on the municipal side because they really don't have the it's tough to go to a commission and say, hey, for 10% more we can do concrete. Sometimes it's tough for commissions that aren't going to be on the boards and the commissions for a long time to accept that. We have some cities that just say, hey, if the concrete bid's within 10%, we're going to go with the concrete up front. What you want to do, and what makes everybody happy and alleviates a lot of arguments, is put it in the specs and the contract documents how you're going to make a decision. So if you're going to have a life cycle cost adjustment, put it in the contract documents. If you're going to make a decision based on, hey, if it's 10% higher the concrete, we're going to go with concrete. And at least people know going in, and nobody thinks you're trying to pull a fast one after the fact. That makes it easier for everybody to swallow. So it just really depends. We love a life cycle cost adjustment on all these jobs, but hey, we know that's not always the case. So
certainly. And with that, Todd, we did run a little bit long, so I do appreciate the audience sticking with us here today. I think we've had a tremendous afternoon. I want to thank Todd. I want to thank Brian. I want to thank Eric for sharing their knowledge with us.